What if everything we've been taught about reality, the solidity of matter, the separateness of minds, is not just incomplete but a narrative that confines human inquiry? For centuries, visionaries who challenged institutional dogma faced persecution and ridicule. From Galileo's trial to the silencing of quantum pioneers, the quest to understand consciousness has been met with fierce resistance. In this journey, we'll uncover three acts of suppression: the medieval church's condemnation of cosmic truth seekers, Victorian science's rejection of heretical discoveries, and modern academia's marginalization of those probing consciousness beyond materialism. We'll ask, why does the materialist worldview cling to its dominance? And what happens when we dare to see reality anew? Join us as we unravel the mind-matter problem and the unspoken struggle to redefine how we perceive existence itself. To understand the so-called Church of Materialism, we must first confront a recurring pattern of events where institutions silence ideas that threaten their authority. Let us begin in the medieval period, where the Catholic Church's geocentric dogma collided with cosmic truth. In 1633, Galileo Galilei stood trial before the Roman Inquisition. His crime? Defending Copernicus's heliocentric model, a direct challenge to the Church's Earth-centered universe. Forced to recant, he spent his final years under house arrest. His work banned. The Church's authority hinged on a static cosmos. Galileo's telescope threatened to unmask it as an illusion. Giordano Bruno, a philosopher-monk, met a far grimmer fate. He proposed an infinite universe teeming with worlds, a vision that dismantled the Church's finite, hierarchical cosmos. To the Inquisition, this was not mere astronomy. It undermined the divine order they enforced. In 1600, Bruno was burned alive. His execution was a warning. Ideas that expand reality's boundaries risk collapsing power's foundations. By the Victorian era, science had become a new orthodoxy. Ludwig Boltzmann, pioneer of statistical mechanics, argued reality was shaped by atoms and probability, not Newtonian certainty. His peers ridiculed his theories as abstract folly. In 1906, isolated and despairing, he took his own life. Only later did his work gain recognition, a posthumous vindication that underscores how institutions often lag behind their visionaries. In 1847, Hungarian physician Ignaz Semmelweis discovered hand-washing could prevent childbed fever. The medical establishment, steeped in tradition, dismissed him as a heretic. Branded a madman, he died in an asylum in 1865, of sepsis, the very problem he sought to address. Germ theory later vindicated him, but his ordeal reveals a timeless truth. Progress demands unlearning what institutions claim to know. In 1952, physicist David Bohm proposed the implicate order, a quantum reality where consciousness and matter intertwine. Mainstream science, anchored in materialism, sidelined him. Colleagues labeled his work mystical, and McCarthy-era suspicions of his politics compounded his isolation. Yet today, his ideas inspire quantum biology, challenging the reductionist view of life as mere machinery. Hugh Everett III met a quieter fate. His many worlds interpretation of quantum mechanics, suggesting infinite parallel realities, was dismissed as fantasy in 1957. He abandoned physics, dying in obscurity. But a 2013 Scientific American survey found 52% of quantum physicists now accept some form of his theory. Everett's legacy? a reminder that today's heresy might yet reshape tomorrow's science. From Bruno's flames to Boehm's exile, one thread binds these stories. Those who push the boundaries of understanding, confined to their time, met a similar fate. But if suppression persists in our enlightened age, what truths might we still be denying? In the present era, the clash between radical ideas and institutional orthodoxy continues. Meet three scientists whose work probes the limits of materialism, ideas that challenge conventional paradigms, sparking both fascination and controversy. Imagine if the laws of nature weren't fixed, but evolved through habit. Biologist Rupert Sheldrake, a Cambridge PhD, proposed exactly this in his 1981 theory of morphic resonance. He suggested that natural systems, like flocks of birds or even human minds, learn and remember collectively, as if guided by an invisible field. While morphic resonance remains outside mainstream acceptance, Sheldrake argues it could explain patterns in nature that conventional biology cannot. Think of how birds suddenly veer in unison without a leader. Sheldrake proposes this could be nature's habit, not just instinct. When Sheldrake critiqued rigid materialism in his 2012 book, The Science Delusion, the backlash was swift. A Nature Journal letter compared his ideas to Taliban theology, revealing how deeply the establishment guards its boundaries. Yet, his work persists, asking, could consciousness extend beyond the brain? And why does that question unsettle science? Have you ever felt a pang of dread moments before bad news? Dean Radin, a former Bell Labs engineer, turned this intuition into science. In experiments, participants' bodies often react seconds before seeing emotionally charged images, a phenomenon Radin calls presentiment. In one study, published in the Journal of Scientific Exploration, skin conductivity spiked before subjects viewed disturbing photos, as if their bodies sensed the future. Critics dismiss this as statistical noise, and Radin's meta-analysis of 90 studies, published in his book Real Magic, claims statistically significant results, though critics contend methodological biases. The odds he cites, 20 quintillion to 1 against chance, suggest something deeper to his supporters. The American Psychological Association labels such findings anomalous, a term that sidesteps uncomfortable questions. If consciousness can brush against the future, what does that mean for free will or fate? Picture the most vivid dream you've ever had. Now imagine it feeling more real than reality. That's how volunteers described their experiences in psychiatrist Rick Strassman's 1990s DMT trials.
It was such a profound experience to have been out there in deep space. And I'm not the kind of person that would have expected this kind of experience. I mean, I would have expected, if someone were to tell me you're going to take this drug that's going to launch your consciousness, I would have expected that I would see angels and fairies and not alien life forms. I have no interest in that. That's not part of, I've never liked science fiction. I've never been into any of those kinds of things. It's not part of any sphere of interest, but to be out there with these other life forms, this greater intelligence, was absolutely astonishing.
What DMT is offering us is a different modality of perception to allow us to comprehend and grasp and interact with the wider reality that surrounds us. And maybe this is why it's there.
Can these medicines not only affect the psychological state of us, but also our bodies? Can we really heal ourselves, our bodies?
DMT, a compound made by the human brain, induced encounters with entities participants swore were autonomous. Strassman's book DMT, The Spirit Molecule, details these accounts. He cautiously suggests the brain might act as a receiver of consciousness, a provocative idea that remains unvalidated in mainstream neuroscience. Though his work was peer-reviewed, funding vanished. Critics accused him of mysticism, but Strassman's research reignites an ancient debate. Is the mind a prisoner of the brain or a window into something larger? Sheldrake, Radin, and Strassman are not lone mavericks. They follow in the footsteps of Galileo and Boltzmann, daring to ask questions that blur the line between science and philosophy. Are their ideas fringe or the frontier of a new paradigm? The answer perhaps lies in how willing we are to let go of old certainties. What does it mean if consciousness isn't confined to the brain, or if the universe itself is far less material than we assume? To grasp the stakes, we must first understand the rift between two worldviews, the classical and the quantum. Classical science, built on Newtonian physics and Darwinian biology, sees reality as a machine. Particles collide, genes dictate life, and consciousness is often framed as a byproduct of brain chemistry. This reductionist framework underpins modern technology, medicine, and economics. But quantum science paints a stranger picture. Particles exist in superposition, time bends, and particles communicate instantaneously across vast distances, a phenomenon Einstein called spooky action at a distance. Emerging studies in quantum biology, such as those published in Nature and PNAS, suggest processes like photosynthesis and bird navigation might exploit quantum effects, though this remains a topic of ongoing research. Researchers like Sir Roger Penrose hypothesize that quantum processes could occur in microtubules within brain cells, a proposal detailed in peer-reviewed journals like Physics of Life Reviews. However, this remains contentious, with mainstream neuroscience citing insufficient evidence. These ideas hint at consciousness as a non-local phenomenon, existing beyond the physical brain. Yet for now, they challenge a core assumption that consciousness is merely a biological accident. Could consciousness be woven into the fabric of space-time itself? Theoretical physicists, including Nobel laureates like Carlo Rovelli, explore unified field theories that aim to merge gravity and quantum mechanics. Some models, such as those in Physical Review D, even propose links to dark energy, though these ideas remain speculative. For instance, dark energy, which drives the universe's expansion, remains unexplained by classical physics. A 2022 study in Physical Review D proposed dark energy as a quintessence field interacting with quantum particles, an idea still far from consensus. This isn't mysticism, it's testable science. The 2022 Nobel Prize in Physics honored experiments proving quantum entanglement, forcing even skeptics to accept its reality. Yet applying these principles to biology or consciousness remains fiercely debated. These debates aren't academic trifles. If validated, they'd force us to rewrite textbooks. Medicine might prioritize mind-body connections over purely chemical treatments. Energy systems could harness quantum coherence. Some philosophers argue that materialism's focus on separateness might influence cultural narratives around consumerism or environmental stewardship. Materialism's strength lies in its simplicity: measure, predict, control. But quantum science and consciousness studies ask, what if reality is participatory? What if observing the world changes it, as quantum experiments suggest? The implications are profound. If consciousness is fundamental, not emergent, it reshapes ethics. Are we responsible not just to each other, but to the fabric of reality itself? And if the universe is interconnected, what does that mean for how we wield technology, govern societies, or confront crises like climate change? The answers remain uncertain, but history teaches us that today's heresies often become tomorrow's truths, and a deeper question echoes: can science evolve without shedding its foundational myths? If quantum science forces us to rethink reality, why does its integration into mainstream institutions face such resistance? To answer this, we must examine the intersection of science, power, and control. Today's energy economy relies on fossil fuels and centralized grids, a system worth trillions. In 2020, Nature Energy highlighted advances in materials like perovskites that could significantly improve solar efficiency. If scaled, this might democratize energy access. But a 2016 Harvard-MIT study found that 78% of U.S. clean energy patents are held by large firms, many with ties to fossil fuels. Innovation walks a tightrope between progress and profit. The global pharmaceutical industry, valued at $1.48 trillion, thrives on treating symptoms. Yet a 2018 meta-analysis in JAMA Internal Medicine, led by Harvard researchers, found mindfulness practices as effective as antidepressants for mild to moderate depression. Imagine a healthcare model prioritizing prevention over pills. The question is not just scientific, but economic. Who benefits from maintaining the status quo? Quantum computing promises breakthroughs in AI and encryption. Google's 2019 experiment solved a problem in 200 seconds that would take classical computers millennia.
It's grown tremendously. It grew from 10,000 years in 2019 to 10 to the power of 25 years, or in words, 10 septillion years on the Willow chip. This illustrates the double exponential growth in compute power.
There's an interesting aspect to the superiority of the quantum computer. The Google hardware has improved a lot in recent years, as we've been hearing, but it still makes lots of mistakes. So they have to run it many times in order to extract a usable signal that can be compared with that classical simulation. They in fact run it millions of times, but they can do that in just a few minutes, which is still a very short time compared to the resources you would need to do the same simulation on a classical machine.
Yet experts warn this power could empower surveillance if governance lags. The race to dominate this frontier isn't just technical, it's geopolitical. Some scholars argue that materialism's dominance grew alongside industrial capitalism, framing humans as cogs in a machine, a worldview critiqued by philosophers like Michel Foucault. Today, the materialist narrative fuels consumerism and alienation. But if quantum science validates interconnectedness, it challenges systems built on division. Is resistance to such ideas merely scientific caution or a defense of entrenched hierarchies? Paradigms protect power. The Catholic Church silenced Galileo to preserve cosmic authority. Victorian doctors rejected germ theory to protect their prestige. Today, a 2022 Pew Research poll found 58% of Americans believe science is influenced by corporate funding. The battle for reality's blueprint isn't just about truth. It's about who gets to define it. As quantum science chips away at materialism's walls, we must ask, is the disconnect between old and new worldviews accidental or deliberate? We've traversed centuries of silenced ideas, quantum riddles, and the uneasy marriage of science and power. Now we arrive at a question. Where do we go from here? If consciousness is non-local, interwoven with the universe itself, what does this mean for how we live? Philosopher Ervin Laszlo's Akashic field theory posits a cosmic memory connecting all life, while the Orch-OR hypothesis frames consciousness as a quantum process. These ideas, though unproven, invite us to reimagine ethics, ecology, and even economics. Imagine a society that sees itself not as isolated individuals, but as threads in a vast, evolving tapestry. Studies in collective behavior, like MIT's 2021 work on swarm intelligence, show how groups achieve feats impossible for lone actors. Could this be a blueprint for a new paradigm? The climate crisis demands collective action, yet materialism's every atom for itself narrative stifles unity. If science begins to validate interconnectedness, might it finally align our values with our survival? To embrace this shift, we must first unlearn. Neuroscience confirms that beliefs, once entrenched, form neural pathways resistant to change. A 2020 Nature Human Behavior study found that even faced with contradicting evidence, people often double down on prior views. This isn't a call to abandon skepticism, it's a plea to wield it wisely. Question not just radical ideas, but the assumptions we've inherited. As David Bohm once wrote, the ability to perceive is crippled when the mind is certain. Curiosity is the antidote to dogma. What if we approached these ideas not as converts or critics, but as explorers? The goal isn't to accept or reject, but to question, connect, and wonder. After all, every scientific revolution began with someone asking, what if we're missing something? Like a kaleidoscope, reality reveals new patterns when we shift our gaze. The choice is ours. Cling to the comfort of old lenses or embrace the disorienting, dazzling possibility of seeing anew.